Okay, let me go ahead and share the screen here. And I want to share, where are you? All right. I think we're recording. Yes, we are. Welcome to week one of CGIT 225. I'm Brother Stedrick. I will be your host on your journey into the world of database design and administration. Here in week one, we got a couple things we need to do. This is the normal Wednesday night session, but I'm alone here, so I'll just make a quick recording and give you guys some information on how to move on and some background information and things. All right, so week one is installing SQL. There is a short video that I'm attaching with this one. Myself and another student installed MySQL together, and you guys can walk through it and see how it worked. It's very short, it's very quick. Installing SQL is not a big deal. When you download it, if you follow the instructions on the PowerPoints, it'll work just fine. But as you saw, Ethan had a little bit of a hiccup, and we walked through it and got it all fixed. What I want to talk about today is the second half of the lesson is actually getting into SQL Server, to MySQL, and doing stuff there. And I want to talk about a couple of things that you'll be doing, so there's a better idea of what you're talking about here. So once you're done, you'll have a screen that kind of looks like this. You won't have these schemas over here, but if you want to, when you want to connect to the database, if you click on database over here, you'll have connect to database. You choose that, and if you just leave this blank and click OK, it'll connect you. It'll look like this. It'll show you all the different, show you the database. You only have one database on your system, so that's the one that'll come up. Click OK. Bob's your uncle. It's connected. And here's another connection to the same thing over here. Okay. Let me close this out. Okay. So once you're all connected, they're going to ask you to create tables and add information. But I want to go over quick a couple of things just so you know the commands that you're using and kind of give you my 2 cents on them. So the language that we use in MySQL or Oracle or Microsoft SQL Server is something called T-SQL. It stands for Transactional Structured Query Language. I have that right here, T-SQL, Transactional Structured Query Language. And there's a reason why it's called this. First of all, it's called a structured query language because there's a structure to it. There's a very definitive, and as we go through the examples, everything has a pattern, and it's always done the same way. There's really not a whole lot of difference. A select statement is a select statement because it has the same basic elements every single time. You can add stuff to it. You know, you have a cupcake, and you have frosting on the cupcake, and you put sprinkles on the cupcake, and a candle on the cupcake, and a Hershey Kiss on the cupcake. It's still a cupcake. It's still a cupcake. So you're not doing anything different with the cupcake. You're just adding stuff on top of it. So a SQL command is like a cupcake. I'll give you a minute to go get a cupcake because I know I won't win it too. All right. So it's called transactional because everything you do in SQL Server, whenever you're writing queries, is transaction based. Meaning, if you have a piece of T-SQL code that is 500 lines long, that is one transaction. Meaning everything happens, and so everything happens, boom, 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 boom. And the database is being used until that last line is done. If you're doing 110 insert statements in a row, that table you're inserting into, that database you're inserting into, is locked until you're done with the insert statements, because it's one long transaction. Okay. You can break up the transactions, make them smaller, which is usually recommended. We'll get that to more later. I mean, there's a whole deep dive section on transactions and stuff like that, but just understand, whenever you hit the run command, everything that you've got printed there runs as one transaction. It's like, again, think of it like, you know, you're at the grocery store and you're buying 120 things. They'll scan all 120 things. That's one transaction. But let's say, you know, your buddy asked you to pick up, you know, a notebook for him. You have to pay for that separately. So your 120 things go, they ring that one up, and then the notebook goes. That's a separate transaction. Okay. So TC will run in multiple transactions or just one transaction, but every command you issue is considered a transaction with the database. And there's a bigger, deep reason why we do transactional. We'll go into that later. That's not a week 1 conversation. It's like a week 5 conversation. So I'll see you in week 5. All right. There are actually 5 versions of languages that we speak in SQL Server, in T-SQL. We're only going to talk about 2 of them today. We're going to talk about DDL and we're talking about DML. DDL is data definition language. What that's talking about is any structure that contains data, okay? Any structure that manipulates data. They're earmarked by 3 commands: create, alter, and drop. Those are the 3 commands of the DDL. And it's pretty self-explanatory. Create makes the object, alter changes the object, and drop gets rid of the object. Boom, boom, boom. Create, alter, drop. And we're going to go through them in a second. We'll go through the create object. But so create creates an object, alters an object, and drops an object. Things you create tables, you create views, you create stored procedures, you create indexes. These are all objects that contain or manipulate the data. Okay. Speaking of manipulated data, DML language. DML is data manipulation language. These are any commands that change the state of the data within the objects. Change the state of the data within the object. Has nothing to do with the object itself. Has nothing to do with the table. Has nothing to do with the view. Has everything to do with the data inside the object. These commands are insert, update, delete. Delete. I can't spell. D-E-L-E. D-E-L-E-T, and select. And we're gonna add one in here, truncate. That's a DML language. There's controversy on whether it's DML or something else, but it actually is because you're dealing with what's inside the table. Okay, so first one, select. Sidebar. The cool thing about Transact SQL, the interesting thing about it, is that the code reads like English. There's no weird commands like CLR or things, well, there are, but later on. But for the basics, the cupcake part of it, it's select, it's create, it's English. Go create this. If I said, go create a cupcake, there would be no question as to what I wanted you to do. Same thing with SQL, go create a table. And here's the parameters of the table. Go select from this table. Go select a cupcake. Okay. So select gathers data from an object and brings it to the screen for you to look at or use. Insert inserts data. Update changes data. Update is what we call, update is an insert and a delete at the same time. Okay. Update is an insert and a delete at the same time because you're updating a table, so you're inserting a new value and deleting the old value. It's 2 separate transactions. Delete deletes an object. Truncate flushes an object. And here's the difference. If I issue the command right here, let's say I've got a table called items. If I use the word delete, if I use the command, say delete items, what it's going to do, the SQL engine is going to go and say, let's say there's 1,000 rows in items. It's going to go through one row at a time. Delete row 1, delete row 2, delete row 3, delete row 4. And it'll go through R-bar, which stands for row by agonizing row, R-bar through that table until the last one is gone. Truncate, however, just flushes it. What's a good example? I don't know. There's this old game where you picked up like a daisy or something with flower petals, and you go, she loves me, she loves me. You pull one petal off at a time, right? So that's delete. Taking that same flower and putting into a paper shredder, that's truncate. So truncate doesn't log anything, just flushes the table. No data anymore. It's done. Okay? So these are the two things we're going to deal with. We're going to do with create, alter, and drop. Insert, update, delete, select. We're not going to talk, truncate doesn't exist in this week. So I'm going to go through the commands that you're supposed to be doing. Walk through them with you. You'll still have to do them and submit them. Walk through the architecture and the pattern of this things. We're going to talk about data types, a couple other things. But right now we're just going to walk through the series of commands that you're supposed to do. I'm using MySQL Workbench. You are welcome to use MySQL Workbench. Feel free. It's the way I like to do it. I think the labs sometimes ask you to do it in the command prompt. Just between you and me, you can do it in Workbench. It's totally fine. So let's look at this first create table statement. The anatomy of it makes perfect sense. Create table person. I want the table called person. Okay. Hang on one second. Okay, so here we go. We've got create person. I took a word called unsigned out there because I didn't want to confuse things. It doesn't need to be there. It's not mandatory. Yeah, create person, create table person. You're saying create this table person. And then in here, you've got the columns that are going to go in there and the data types. So this is kind of important. I want to talk to you real quick about data types. I'm not sure how long this is going to go, but let's see where I'm not going to go super in depth on data types. The data type is telling the create statement and the database what type of value it expects to be in there. Is it going to be numbers? Is it going to be letters? Is it going to be date, time, whatever? Because you want to be able to format the data in such a way that when you pull it back out, it makes sense. You don't want everything just to be like kind of text file, and you can't do any mathematical operations on numbers or anything like that. So you want to make sure it's a number, date, time that you tell the table exactly what's going to be in there. So person ID is small int. So what small int means is that it is a small integer anywhere between negative 32,000 and positive 32,000. That's 32,767. But anywhere between negative 32,767 and positive 32,767. It's important to decide the value of the data type you're using for a column for a couple of reasons. Number one, if you're creating this database for a business, and this is the person table is going to be like all your employees and your customers and everything, and you plan on having over 32,776 people or 767 people in your organization, you probably shouldn't use a small int. You can change it after the fact. You can. However, it's kind of difficult to do it, and I don't recommend it. Planning ahead is the smarter choice. Because if you have 32,000 people in your organization and you have to change this to int, which goes up to memory serves 2 million something, it's going to take a while to convert that column. Also, a small int takes up, I think it's 8 bits. Let me double check real quick. It doesn't say. I believe it's 8 bits is what it takes up. So conversely, or initially, int takes up 16, big int takes up 32, and on from there. So you may not think it's a big deal, but let's say you did everything in small int, and so small int 32,000 is a lot of bits. I have another video that talks about this specifically. So if you have 32,000 small ints, and then you jump that to an int, you are literally doubling the size of that column on your disk. And it may not seem a big deal, but 8 bits is, okay, I gotta do the math here. Hang on, let me get my calculator up here. Calculator. You can't, I'm just sharing the console so you can't see what's going on. So 32,676 times 8 bits, 261,000 bits. Okay, so if you have 36,000 rows using a small int, that's taken up about 32K kilobytes of space on your disk. If you double that, it becomes 64K, which doesn't sound like a big deal. But let's say instead of doing small, use int, which is 2 million some odd, okay? So 2 million some odd rows in that one column alone. So the one column taking up this space on the data, one column alone is 15 gig at 16-bit each, if my math is right. If my math is wrong, let me know in the comments, and that's totally cool. My math is off. But if it is off, it still makes the point. So it's 15 gigs, okay? If I change that to a big int, it becomes 30 gigs. And that is a substantial difference in a database because you're doubling the size of that column and that column alone, okay? So if my math is off, I'm cool with that. But the point is, if you choose a data type like small int and then change it to an int, it doubles the size of that column. If there's a lot of data, a lot of entries in that column, if you got like 6-7 million rows in there, you're making a considerable change. I worked for a company and they had, we had set it to int before I'd gotten there because they never expected to reach over 2 million people. And when I got there, they were at like 1.9, almost 2 million. And we had to upgrade from int to big int. It took something like 22 hours and doubled the size of the table. So plan ahead, you know. Sometimes it's inescapable. If you think you're gonna have a small business, all of a sudden, like everyone loves your business, you got tons of customers, that's one thing. But if you think that it's gonna happen, make sure you're using the right data type because converting it is problematic. All right. So person ID, small int, first name, varchar 20. So varchar 20, what that means is it means variable character length. So that means this column will house up to 20 characters. Okay. If you put in one character, it's only housing one character. It's taking up room for one character. If you put in 20 characters, it's taking up the room of 20 characters. If you put in 21 characters, you're going to get an error saying, hey, you only said there'd be 20 here, only got room for 20. Again, you got to be careful because changing this, well, changing a varchar doesn't really do the same thing as changing an int because a varchar is always variable. It assumes there's nothing in there, okay? Char, on the other hand, says there will only ever be 2. No matter what you put in here, I will keep room for 2. Okay. So the difference between varchar and char is if I have varchar 20 and I put in 3 characters, it's only housing 3 characters. If I put in char 20, it's holding space for 20 characters. And if you put 1 character in, that character's got a lot of room. Okay. So your first name, last name, birth date, date. There you go. It's just a date. It's got to be in a date format, month, day, year. But that's how it's saved. Varchar. And then down here, we've got our first constraint. A constraint is a limitation put on the database to make searching in life easier. A primary key tells the table, this is the most important column in there. And I always want you organized by that column. I keep it in the desk and it keeps moving my camera. So this is saying here, constraint per PK person, that's the name of the constraint, is going to be the primary key, and that's going to be the person ID. That means this column is the most important column in the table. That is how everything is going to be organized by. Okay. So I take this. So now the fun thing about using, so first of all, if I try to run this as is, it would cause a problem. You got to put this statement at the top in case you haven't done it yet. The use statement. So over here on the side here, these are schemas. Sakila, student database, and sys and world. These are schemas within your database. You have to tell them which schema you want to use with using a use command. Now, the fun thing about using Workbench is if I just highlight a command and hit this little it just operates, it just runs that portion. So everything else here can sit. So let me get rid of this here. Oh, and you'll see that there's a little error here saying this won't run right. It's because there's no semicolon here. And now it's going to be fine. Every command must end in a semicolon. Excuse me. Okay. So here. So let me run this here. And I'm going to execute that. And I get here. Oh, you have an error in my SQL. Oh, let's see what it is. I forgot that last part. So let me do this. All right. 0 is affected. If I look over here, hit refresh, boom, I got a table. I click here, boom, I got columns. Okay. Okay. So so there's your create statement. Person ID, small n, var chart 20, chart 2, blah, blah, blah. Tables created. Got it over here. Next, they want you to create a, let me get rid of that here. They want you to create a favorite food table. Okay, so create table of favorite food. Person ID, small int, food, varchar 20, constraint. Okay, constraint. We're gonna make a primary key right here. Call it PK favorite food. And the primary key has to be unique. It can't have a duplicate. So here it's saying person ID and food is the primary key. Over here, just person ID is the primary key. Here, it's person ID and food. So it's 2 columns. I think up to 3 columns, maybe 4 can be the primary key. And even if you're allowed more than that, it gets messy if you add more than 3. So you can have 2 keys of primary columns. So those 2 columns together must be unique. And they will be what the table is sorted by and what the table is stored as. And then over here, we've got another one called constraint, F key, favorite person food ID. Here it's a foreign key. And we're foreign keying the person ID column here and saying it references the person ID column in person. Basically what this means is you cannot put data into this table that does not have a referring person ID in the person table. This is for data purity. It's a better word for it. Consistency, thank you. Data consistency. We want to keep our data consistent. We don't want to have person ID 64 being listed here when there's no person 64 on the person table. I'll show you what happens if you do this, do something wrong here on the part where do some errors. Let's use some errors. So create favorite food, again, just create a table of favorite food. Person ID, small int, food, varchar 20, constraint, primary key food on person ID and food, and then a foreign key constraint. Highlight it, run it, and now we've got another table over here. Okay, I'm gonna jump real quick to the drop command, just so you can see it. It's right here. All this does, it gets rid of the table. Data, everything, constraints, whatever, it's gonna break it. Okay, it's gonna get rid of it. So we're gonna delete person first. Okay, we've got a problem. Look down here on the error. Cannot drop person referenced by a foreign key container. So because this table references person, you can't drop person first. You gotta drop favorite food first, and then you can drop person. Unless you just drop the foreign key, and then you can do it. But that foreign key locks person into place, and it cannot move as long as favorite food refers back to it. It just protects the data. So drop favorite food. Oops, wrong way. Drop favorite food, it's gone. And now drop person, and it's gone. Let me recreate them really quickly because the next bit's gonna be difficult without them. Okay. Okay, so let's talk about the alter statement. The alter statement changes the database to be what we want it to be. Without having to drop it and recreate it, I'm just gonna add on to it. You know, if you wanna build a new room on your house, you're not gonna destroy the entire house to add a new room onto it. You're just gonna add a new room onto it. So we're gonna do 2 alter statements here. Put a little semicolon there so my other statement doesn't have a problem. Okay. So the first thing, we're going to alter the table person. The next command is modify. It could be add, it could be drop, whatever, but we're going to use the modify command on this. And we're going to modify person ID. Keep it small, and we could change the database type at this point, the data type at this point. But we're going to have this command called auto increment, okay? Auto increment is basically saying whenever I insert into this table, just get the last number and put the next one there. It's an auto numbering sequence. It just means you don't have to try to remember what the last ID number was, and you're consecutively 1, 2, 3, 4, 5, 6. Okay. So that we're gonna do that. So it's just going to be just going to be auto numbered. Next one, alter table person, modify eye color, enum brown, blue, green. Okay, so what this basically is saying, this enum command is saying, okay, this is putting a constraint on the table. Okay, it's called a check constraint. It's just a different way to do it. It's basically saying, if it's not one of these three values, it can't go into this column. If you don't have brown eyes, blue eyes, or green eyes, we don't want you in our column. If you got hazel eyes, you're out. Gray out, done. You're not allowed there. We're allowing the three: brown, blue, green. So let me go ahead and do these. Okay, execute that one. Up. Oh, okay, hang on a second. That is a good point. So I need to, that's my bad. I can't alter that table as long as the foreign key is there. So let me drop the table so I can make the alteration to that. So drop that. Let me go here and then make the modification. Okay, and let me recreate the table. Okay. So you see what I do there? Because the foreign key was on person ID for food, I couldn't change that column. I couldn't do anything to it. So I had to go and drop their favorite food. Now, if you got full data there, don't drop the table. Just drop the constraint. It's just alter table, drop constraint, and then you can recreate it later. All right. Let me go ahead and do the modification here. Okay, so now, if it's not brown, blue, or green, you can't put it in there. So let's look at, so those are your alter statements. So let's look at our insert statement here. We got a couple of them here. Insert into person, person ID, first name, last name, eye color, and birth date. Now, here's the thing. That doesn't need to be there. This command will run just as well without those there. But I recommend that you leave them there. Because right now we're only inserting into 1, 2, 3, 4, 5 columns, right? What if you're inserting into like 85 columns? How are you going to know, make sure that the values are there? Okay. So it's a good idea it's a very good idea to leave these here. That way you're making sure the right values are in the right place. You're never missing a value. Like if you did it and like here, like let's do, I'll show you that error in a second. So let me run this one here, execute that. And if I go here, do select star from persons, and I run that, there's my results. Nothing else is there, just those, okay? If I did this and got rid of person ID and got rid of the null, and I change this to Bruce, let me get my, let's look up Bruce, change that to Wayne, change that to green, okay? And I ran this. It ran fine. I left person ID at why? Because it's auto numbered. See, it just got there, it's auto numbered. I don't have to put there with the null, I can leave it out altogether and it will just automatically auto number. But if I do this, and I get rid of this, right? And I get rid of this, okay? And I change this to Prince, change this to Diana. and change this to blue and run this. I'll get that comma out of there. And I run this. I get an error. It says column count doesn't match value count. What this is saying is this table, where's this? This table requires 1, 2, 3, 4 values. Everything else, if you look back here, okay, requires those values. Okay, it requires all of these to be there. Everything here must be in that insert statement, but it's not back here. Okay, so it's not. So let me zip back here. Actually, let me copy these real quick so I don't have to do that again. Copy. Okay. I do that, and they're back now, right? Even though these aren't all there, they're all nullable columns, okay? Person ID isn't a nullable column, but all these are nullable. But if I'm saying insert into person, I leave everything blank, it's expecting a value for everything, but not so. So here I do this, and I execute, and it's there, and I do select from person, and I look at it, and I got 3 of them. Now let me do one last one, and let me do this here. Let's say we got. If you didn't know this, I'm doing a bunch of DC characters. So here is. Let's see if anyone knows who this guy is. Alan Scott. He's from DC. Let me know if you know this. So we got Alan Scott. Alan, AG. That's not here. And then his birthday. And I do this. And I do this. And I get an error. Data truncated for column eye color row 1. They're saying, hey, this isn't allowed there. You can't have that there. If I go here and add it, it'll be allowed. If I just go here and change it to blue, that's fine right there. All right. And then I go to here and I select person. And I click my little thing. And now I got 4 people there. And I go, Ivan just popped in, so let me pause the recording here. Okay. Okay, Ivan just showed, Ivan Rowe?
Yep, you said it right.
Yes, it just showed up and he had some questions about what I was talking about. So we're gonna pause what we're talking about here and have him go hit through his issues, and then we'll go back to what I was talking about. Okay, show me what you got, buddy.
All right, can you see my screen?
I can.
Perfect. So I posted a question on the discussion page saying, like, hey, I followed through all the steps that were in the syllabus or in the assignments or whatever, and I just wanted to make sure I did it right.
Hmm?
So a lot of people commented on it and said, hey, this is how you check it. And so basically from here, we can go to the connections.
Yep.
And then down here, go to schemas.
Yep.
And then it should just be right here, student database.
Yep.
But then what are all these? Like I click on them, nothing's happening.
Well, it's because you haven't made anything yet.
Oh, okay. That makes more sense.
if you follow the are you using the PowerPoint slides?
Yes.
Okay, so once you get past, when you go into lessons 2 PowerPoint slides, they start teaching how to create tables.
Oh, okay. Okay.
Okay, so you gotta go through the create statements and all that stuff there. But yeah.
Okay. Yeah, I haven't gone through number 2. I just went through chapter 1.
Yep, no, right now you're exactly where you need to be at the end of chapter 1. So look at the PowerPoint slides of chapter 2, and they'll go through create statements, and then the video that you are currently on, that I will be posting later tonight, helps you walk through the exercises on how to do the create statements.
All right, perfect. Then yeah,
okay.
I think I'm all caught up to speed then. Thank you.
Awesome. Thanks for stopping by.
Yeah.
You can hang around and listen to the rest of this while I'm doing it. I'm on the alter statements, so feel free to stick around while I talk about the rest of this.
Yeah, I'll definitely do that. Thank you.
Okay, here's where. Okay, so we just gone through. So we did the alter statements here, and like I said, because this said Hazel, and I can do this. It doesn't. There's no primary key, so I do this. If I try to run this, again, I get an error saying the data is truncated. So data truncated column isn't like a great error. It's basically saying there's something wrong with the data, and your data truncated usually means it's too long. Well, that's a lie, because it's not too long. It's just that it's not one of these values. But if I go here and I add that value, and I alter my table, oh, not NZ, that's not New Zealand, we're looking for Hazel. There we are. And I go ahead and alter this here, and I run it, and it's fine. And I go here and run this again. Look, it worked now, because I added that value to saying these values are allowed. And if I go here and I run this, okay, there we got 2 Alan Scotts, one has Hazel Eisen. Everyone has the same birthday because I'm just lazy to change it. Okay, so insert into favorite food. So now we're inserting into a different table. And remember, there's only 2 columns. There's the person ID and the food ID, or the food name. And if I do this and I run it, it's happy in it inserts. And I do a little select from favorite food. Little semicolon there. And then I do this. Did I spell dogs right? Oh, sorry, I gotta put a star there. All right, select. Basically, star means all. So select everything from favorite food. I click my little, and look, everything's there, 1 pizza. So now, if I try to run this again, I get an error. Duplicate entry, primary key has been violated. Because remember, the primary key on this table is person ID and food, and it has to be unique. It can never happen again. Okay. If I do 3 pizza and do this, it works fine. I go here. And now we got that, and remember who was number 3? I forget who number 3 was. I think it was Diana Prince. It was Diana Prince, and obviously her favorite food is pizza. All right, but here we'll do value 1, cookies. Okay, that worked too, because remember, it's person ID and food. That's the primary key. Okay, so as long as those 2 values are unique, it's fine. And let's do this. Let's say number 32. 31 is fine. Their favorite food was cookies. And I try to insert this, and I get an error. Can add or update a child row at foreign key fails. Remember what I said. The person ID column in this table is foreign keyed to the person ID column in this table, in person table. If it is not there, it cannot be put into the favorite food. There is no person 31 in this. There's only up to person 5. So if I try to do any other value, I'm going to get this error saying cannot add or update a child row. The constraint fails because it's not there. Okay. So I'm doing this to show you the errors that you will see, so you don't get all the errors. If you get errors in SQL, it's totally fine. They generally say what they are. A quick Google search will help you explain it, or ask me and I'll help you figure it out. But getting errors is totally fine, and expect to get errors. But don't worry about them. Okay, so I think I'm gonna have a visitor walking by me. There's my son walking to get his switch, because it's switch time here. Okay, update. The update statement. You're just inserting and updating into the table. Okay. Okay. If I look at person here, let me back up. Let me get this put down here. Let me bring you down here. Come down here, my little friend, so I can take a look at you. Okay. Okay. I was right here. So I do this. I got nothing in street, city, state, nothing there, because I didn't put initial in there initially. So I can do this, and I update the person. I click this, and I'm saying update. Set the street to this street, the city to Boston, the state to Massachusetts, the country to USA, the zip code to that. Where person ID equals 1. This is the most important statement in this entire query, and I'll explain why in a second. So let me do this, and I'll hit this, and I'll select from person. It worked just fine. I got 1 row affected. I do select person, and look, William Turner now is the place that he lives. Now, Remember when I was creating this table over here earlier and I forgot that last line and it failed out saying it was the incorrect SQL? Well, let's say I forgot that last line and I ran this. Oh, okay, that's fun. Normally that would completely break, and I'll shoot. Let me double do this here and put this here, and then just run this. Oh, okay. Oh, because we're in safe mode. Oh, yeah, okay. So if we weren't in safe mode and I did that, every column would change. Okay. So because MySQL has a safe mode, which Oracle and Microsoft SQL Server do not have a safe mode, you would have changed every row in that column, every row in that table to this address, which would be a bit of a problem. Okay. So there's that. So you can change it to whatever his person ID is 3, maybe maybe Bruce and William live together. Okay, because Wayne. There you go. And now they both live in the same place. Okay. So that's how we update. And the last one is delete. We want to delete from person where ID is 1. So I'm going to go ahead and do this. And I'm going to do this. And hit that. And look, it fails. Why does it fail? Because there's a foreign key on it. As long as there is a foreign key on it, we cannot delete it. So that becomes a problem. But let me test something out. I don't know if safe mode stops this. Let me see here. Let me do it here. Let me do this. Copy this. And then do this. And let me take this and bring favorite foods down here. This may or may not work. I'm not really sure because I also remember what safe mode does. So I'm going to do this. And I've deleted everything from favorite foods that has number 1. And now let me see if I can delete from person. Let me do it. Okay. So that's how smart it is. It checks. If there was a value 1 there, it says, no, you can't do it. Right? But if it looks at the table and see if there's no value 1, we're just going to delete it all. Okay. So now if I look at person and favorite foods, William never existed. We got rid of him because he's not in the DC universe. We don't even know who he was, how he got it. Okay. So there's favorite food, and there's this. Now, here's an interesting thing. If I go back here and change this to Wally West and change it to blue because Wally West eyes are in fact blue, and I run this, do you think it's going to put Wally at ID number 1 or ID number 6? Place your bets. Run it. And let's take a look at it. And place it at number 6. It never goes backwards. There is a command that you can go and have it renumber. Let's say you accidentally inserted like 10,000 rows and you deleted them, but you don't want to lose the numbers. So you can add this command, which we'll talk about later, I think. If not, I'll show it to you, remind me. That lets you go in and reset it back to a specific number. But yeah, so it'll always go to the bottom and take the last one. So there'll never be a number 1 person in this database ever again. Because you can't, because it's auto numbered, since it's auto incremented, you actually can't go in there and put a number in. If I did this and try to do that, it wouldn't work, it would error out. Okay, I think that covers everything from this lesson. Let me stop my sharing here. This will be going up today. If you have any questions, post in the discussion boards, ping me, whatever you need to know. Ivano, thank you for showing up tonight and listening to the last few minutes of it. It makes a difference when I'm actually talking to somebody. Do you have any questions on what I talked about, even though it's like, you still got like a little bit to go ahead of that?
Yeah, I think you're right. I don't really have any questions. I think I'll just have to review what I missed, and then, yeah, I'll shoot you some messages if I have any questions.
Actually, you know what I'll do here? Let me do this. Let me do a quick recap. Let me share my screen again.
Oh, perfect.
Okay, so a quick recap. Okay, so transactional query language is basically the language you're using. It's a structured language that does everything transactionally, means everything happens in chunks. DDL, data definition language, there are 3 terms that we use: create creates things, alter things, drops things. It's pretty self-explanatory. DML is data manipulation language. This this modifies the data in the items. It does not alter the objects itself. So you create a table, but you insert into the table. So the DML language is only to deal with the data that's inside tables or other structures. There's insert, which adds, update, which changes, delete, which gets rid of, select, which selects everything out, and then truncate, flushes. The difference between delete and truncate is delete is one row at a time. Truncate just flushes the whole thing at once. Look at our first create statement. Create table person, person ID, small int, so it's a column name and data type. We go through here, and then we add our constraints. Use the keyword constraint, what we want to name that constraint, and what the constraint is. There's primary key, which means this column must be unique and can never duplicate, but that is the primary key is the column that the entire table is sorted by in memory. In this create statement, this create table, we create favorite foods. Same thing, person ID, small int, food, there we are, there's our two columns. In this case, two columns, the primary key, and that's totally fine. You can have two columns in a primary key. You can have three, anything beyond three is a bad idea, don't do it. But here we also have a foreign key constraint saying that if it's going to go into person ID in the favorite food table, it has to exist in the person ID column in the persons table. Here are my drop commands. They're simple and sweet. Drop person, drop favorite food. Remember, as long as a table has a foreign key constraint on it, it cannot be dropped. I cannot drop person as long as favorite food has the primary, the foreign key on it. If I drop the foreign key, I can drop the table. If I drop the other table, I can drop the table. But as long as the foreign key exists, I cannot drop the table. My alter statements change an aspect of the table. Here, the first one, I'm changing person ID to have an auto increment. That means it automatically numbers starting with 1. In this one, I'm adding an enum constraint, which means the value that goes into eye color must exist in one of these 4. It cannot go off book. It has to be one of those 4. Anything else, you'll get a compression error. Insert statement puts the data in. Whatever is here has to be here. You don't have to put this here, but it makes more sense. That way you know what values are going in where. And then your update statement. We're updating our table. We use the set command to say what columns are being set, and then what values are going there. Set street, city, country, postal code. And then the most important command in here is the where, telling you which one to do, because if you're not in safe mode, then it'll change everything. Delete from person, same thing. Delete from person where person ID was 1. If that's not there and you're not in safe mode and you just run this thing on its own, you're deleting everything in that table. So be careful with that. And with that's a good wrap up. That work for you? That work for you?
Yeah, thank you.
All right, no problem. I'm sure everyone else could use it too. Say hi to my son Landon, who's in the background, who will
What's
be
up,
there
Landon?
forever. My student says hi. You'll be there for as long as the video exists on YouTube. All right, no more questions. Have a good night. I'll talk to you later, Vonro, and talk to you later.
Yep, bye.